Hello, my name is Hugo Morales, and we are honored to share our work here at SEO. Our work title is LoRa, Early Warning System, an artificial intelligence platform for the management of clinical deterioration on wards. These are preliminary results from Brazilian hospitals. Clinical deterioration definition is a serious physiological disturbance or a sudden worsening of patient physiological condition. It affects up to 10% of a hospitalized patient and usually leads to unplanned transfer to the ICU, intensive care unit, or death. We know that patients who experience unplanned transfer to the ICU show evidence of physiological derangement 6 to 24 hours prior to their deterioration. So time is an extremely important feature here. Early warning scores were developed since 1990 in order to early detect patients with clinical deterioration. But what's our standard of care nowadays to early detect patients with clinical deterioration? Onwards, the nurse team usually makes rounds every 6 hours, seeing patient and collecting vital signs. They use early warning score to determine the degree of severity of the patient and communicates to the rapid response team, and the rapid response team can make the diagnosis and start the proper treatment. If the patient stays on the ward, you want to escalate care, which means that the nurse team will have to make rounds more frequently and observe the evolution of the patient. The problem is that 25% of the time, the system doesn't work. And failure to recognize clinical deterioration is multidimensional. We point out here 3 major obstacles. First, it's about data. We have disconnected data. The second one, there's a low accuracy of our tools of detecting patients. Early warning scores use fixed variables and thresholds, and they don't take into account the patient timeline or patient characteristics. And the third one, we have major issues with communication errors. Miscommunication is very common inside the hospitals. The LoRa Clinical Deterioration Platform tackled these 3 obstacles in a scalable way by connecting to the electronic healthcare records, aggregating data in cloud service, and making prediction of clinical deterioration using machine learning models, and by communicating the care team through dashboards and mobile phone. To train and validate our model, we extracted data from 6 different hospitals in Brazil, retrospectively from 2016 to 19, and we compile 121,089 unrepeatable medical encounters, making more than 7.5 million data points. Here you can see the patient timeline during hospitalization from admission to discharge or death. In order to select the data for the training data set, the last 12 hours before patient discharge was ignored in order to diminish the bias, and only the last 5 collection of vital signs prior to that time frame was considered, which gave us an average of 24 hours of patient history. Features selected for the prediction were vital signs, biologic sex, age, ward type, days of hospital stay, and the target variable, the dependent, was patient outcome. Here's our classification workflow. We test several models, and the best, which performed best, was the Light GPM. But it's interesting noticing that in this table, all the machine learning models outperform our current standard of care, LEWS 2 or MUSE. We deliver this information through dashboards, which stays in the hall of the hospitals. So it's very important that every healthcare professional participate, being part of the process. Here's our example of our dashboards. In the middle, the most critical patient. And the left side, the second most critical, the third, the fourth, and so forward. And the right side of the dashboard, we call the observation room. So those patients who already have been seen and have to escalate the care and here the time that they are supposed to see the patient again. We are in 38 hospitals, 23 cities, with more than 3 million unique patients, and our database has more than 8.5 million encounters. We analyzed 2 hospitals, each one 4 wards and another one 2 wards, summing 6 wards in 2 hospitals. 4 months before and 4 months after the implementation of LoRa, we found 2,044 patients, 1,245 before and 799 after, with 80% of clinical wards, 51% female, and the age 45, with no difference between the groups before and after. Some interesting results. The first one, the mean quantity of collected vital signs per patient was very different before and after, suggesting that the implementation of LoRa helps the digital transformation of the unit. We could see also a reduction in length of hospital stay and a reduction, 30% reduction in mortality. Our future work, we know that this is just a small work showing our results, so we are extending the analysis for 1 year before and after, and to 8 hospitals, expecting more than 200 patients. We are looking for scientific partnership and funding for a clinical trial, and also scientific partnership to analyzing real-world evidence, real-world data, since we have more than 8 million encounters. And of course, continuously model optimization and development of new models, like using deep learning for clinical deterioration and also for other outcomes, for instance, readmission, bacteremia, kidney injury. Thank you very much. Here are my contact.